Hello, this is a video where I'm going to work through all the problems from January 26 notes. I'm going to make this full size, and I've left enough room here to work out the problems as you'll see them on your notes, except I have more space in here because I can't write very small with this tablet. Let's start with our four-step problem-solving process. Remember that this is an important skill to be able to translate a problem into algebraic notation. So even if you can solve this problem without using the four-step problem-solving process, I want you to practice this skill anyways. So let's solve this first problem. We have an appliance business that needs to rent a delivery truck. So I need to turn on my write tool. So I am going to start by reading this problem. I'm going to rent a delivery truck for 6 days, and the cost of renting a 16-foot truck is $29.95 per day plus 29 cents per mile. And I have $550 budgeted for the rental. I want to know how many miles can be driven and stay within budget. So I'm going to start here. Step 1. Let x equal miles that can be driven and stay in budget. Now, it doesn't seem like you should have to write this many words, but as you'll see later, it's very important that we're precise about what our variable represents. Now, I'm going to write step 2 as my equation. So I know that the total cost it has to be equal to $550 or less. And I know that that cost comes from 6 days that cost $29.95 per day. So I'm going to multiply 6 by $29.95 plus 29 cents per mile times x miles. So notice that 6 times $29.95, that's dollars. 29 cents per mile times x miles, that's dollars. And there's a number x that makes this statement true. And that's what we're going to find in step 3. What is that number? So I know that 550 is there. And I know that 30 times 6 is 180. And then 6 times 5 cents is 30 cents. So this product has to be $179.70 plus 0.29x. Now, I did the subtraction earlier, and I happen to know that when you take 179.70 from both sides, you end up with $370.30 on the left-hand side and 0.29x on the right-hand side. Now I'll divide both sides by 0.29. And I know that I can multiply the top and the bottom, the numerator and denominator of this fraction by 100 and get 37,030 over 29. That equals x. And now I'm going to move the screen up a little bit, and I'm going to do this long division over here. So my divisor is 29. My dividend is 37,030. And I'm going to think about how many groups of 29 I can make out of 37. Just one. Now I subtract 29. 17 minus 9 is 8. Bring down a 0. 29 times 2 is 58. That's as close as I can get there. Subtract 2, leaving me with 22. Bring down a 3. 29 times 7 is as close as I'm going to get there. and 29 times 7 is 203. Subtract, and I get 20. Bring down the 0. And I know that 6 times 29 is going to give me, let me see, I did this amount. Oh no, apparently I didn't. So I'll just do it again. 30 times 6 is 180, and then subtract 54. You know what? I'm just going to do it again because I'm not sure. 29 times 6 is 4. Carry the 5. 6 times 2 is 12. Plus 5 is 17. 174. And I don't need to do any more division because I clearly defined that x is the number of miles that can be driven and stay in budget. And 1,276 miles is the greatest whole number of miles I can go. So I'm going to call it that, 4. 1,276 miles can be driven. Okay, let's go to the next problem. And again, let's read the problem. The average top speed of the 3 fastest steel roller coasters in the United States is 116 miles per hour. So immediately, I know that I'm going to be adding some numbers up, 3 of them in fact. The average top speed of the 3 fastest steel roller coasters is 116 miles per hour. So I know I'm going to be adding 3 numbers and dividing by 3. And I know that's going to equal 116. Now the 3rd fastest roller coaster reaches a top speed of 28 miles per hour, less than the fastest roller coaster. The 2nd fastest roller coaster has a top speed of 120 miles per hour. So sometimes people think that there are 2 unknowns, but it turns out there really aren't, because the question is asking us what is the top speed of the fastest roller coaster. So let's call that x. Top speed of fastest coaster. Now notice you don't want to just say x equals speed because I don't know what speed you're talking about. Now we know that x represents the top speed of the fastest coaster. And now we can write down our equation. We know that x is the speed of the fastest coaster. The 3rd fastest coaster has a speed of x minus 28 because Superman the Escape reaches a top speed of 28 miles per hour less than the fastest roller coaster. That's a plus. And the 3rd coaster has a top speed of 120. And we know that when we add those 3 speeds and divide by 3, we have to get 116. Now we can solve our equation. I'm going to multiply both sides by 3, and because I'm multiplying both sides by 3, I have a 3 over a 3. That's a factor of 1. So now I have the numerator is x plus x minus 28. And notice that these parentheses, there's a 1 in front of them, so we don't need them. Plus 120. 116 times 3 is 348. I'm going to combine like terms. 120 minus 20 is 100. Minus 8 more is 92. And I'm going to subtract 92 from both sides. 6, 5, 256, 2x equals 256. Divide both sides by 2, x equals 128. Now I'm not done. I need to answer the question that was asked with a sentence. The top speed of the fastest coaster is 128 miles per hour. Let's look at the next problem. The Samuels are planning to sell their house. if they want to be left with $130,200 after paying 7% of the selling price to the realtor as a commission, for how much must they sell the house? Now, this is a great example of a case when you really want to write down all of the steps and pay a lot of attention to the details, because it's easy to get this backwards or to do a computation that doesn't answer the question asked. So notice that the unknown is how much the house must sell for to be left with $130,000. So let X be the sale price before commission. So we already know that X has to be bigger than 130,200, and some people say, oh, I'll just take 7% of 130,200 and add, and that won't give you the correct answer, because 7% of this smaller number is not the same as 7% of the larger number. But what we can do is know that the sales price before the commission, take away 7% of the sales price before commission, has to equal $130,200. So this equation, when solved, will give us X, the value of the house, the value the house has to sell for the Samuels to clear $130,200. Now I want you to notice that there's a coefficient of 1 on this X term and a coefficient of 0.07 on this term. So when we combine these like terms, we subtract 0.07 from 1 and we get 0.93x equals 130,200. And now we divide by 0.93 by 0.93, and x equals 130,200 divided by 0.93. Now I'm going to work through the long division here and show you what the quotient comes out to be. Remember that I can multiply the numerator and denominator by the same number and not change the quotient. So I get 13,020,000 divided by 93. 93 is my divisor. 13,020,000 is my dividend, and I can make one group of 93 with 130 things. 7, 12 minus 9 is 3, so I have 37. Bring down a 2, and I know that 4 times 90 is 360. 4 times 3 is 12. In total, I get 372. Subtract. I have remainder 0, but notice that the ones, tens, hundreds, and thousands place all have zeros in them. So we have $140,000 is the sale price. The Samuels must sell for $140,000. Let's look at the next problem. In a triangular gable end on a roof, so I'm going to draw a picture of a triangular gable end on a roof. The angle of the peak is here, and we'll call this side the back. See, there's this reference to the angle of the peak is twice as large as the angle on the back side of the house. So we'll call this the back side of the house. And the measure on the angle of the front side is 20 degrees greater than the angle on the back side. So we'll call this the front. And we know that we should let x equal, and this is not supposed to be long, it's supposed to be large. We know that, now you might again say, well, there are 3 unknowns here, but there really aren't, because all 3 angles are defined referring to this angle. The measure, the angle of the peak, is twice as large as the angle on the back side of the house. The measure on the front is 20 degrees greater than the angle on the back. So everything is measured in terms of this angle. So let x equal angle on back of house. Now we know that the angle on the peak is twice as large as the angle on the back side of the house, so we can multiply x by 2, and that has to be the angle on the peak, and the angle on the front has to be x plus 20 degrees greater than the angle on the back. So we know that the sum of the interior angles of a triangle must be 180 degrees. X plus 20 plus 2x plus x has to be 180 degrees. Let's solve our equation. Combine like terms. There are 4 x's plus 20 equals 180. Subtract 20 from both sides, giving 4x equals 160. Dividing by 4 tells us x equals 40 degrees. And so how large are the angles? You have to read the question and make sure you answer the question that is asked. The angles are the angle x is 40 degrees, 80 degrees, and 60 degrees. 40 and 60 is 100, 180 makes 180 degrees, so the answer makes sense. Okay, one more. Let's talk about this. The sum of 3 consecutive odd integers is 189. What are the integers? So let's talk about consecutive odd integers. Let's call x the first consecutive odd integer. And we know that odd numbers are always 2 units apart from each other, consecutive odd integers. Notice that to get from 1 to 3 you add 2, to get from 3 to 5 you add 2. These are consecutive odd integers. So we know that the smallest, the first of our consecutive odd integers is x, and we know the next one has to be x plus 2 because of this pattern, and then we have to have x plus 4. X plus 2 more. And we know that sum is 189. Now let's solve this equation. 1, 2, 3 x's plus 6 equals 189. Subtract 6 from both sides. 3x equals 183. Divide by 3 on both sides, and we get x is, now this is 180 plus 3. So 180 divided by 3 is 60, and 3 divided by 3 is 1, so we know this has to be 61. So the integers are 61, 63, and 65. So those are several different examples of word problems solved using the 4-step problem solving process.